Hi, everyone. Hope you're doing well today. Thanks for joining us. Today, we're going to be covering instrumenting Cloud Run with Prometheus or OpenTelemetry metrics. We'll be talking a little bit about that in just a second. Before we dive in, I'm going to go ahead and introduce myself. I'm Kyle Benson. I'm one of the product managers for the Cloud Operations Suite. With me today is Lee Yanko. Lee is the one of our product managers for the managed service for Prometheus as part of our broader Cloud Ops Suite. So just to sort of quickly level set on what we'll be talking about today, I'm going to quick overview of the, sort of the goals of observability. We'll talk a little bit about OpenTelemetry as well as Prometheus. We'll talk a little bit about Cloud Run sidecars, which is a fairly new feature and capability that has allowed for some really interesting support for Prometheus as well as OpenTelemetry metrics. We'll do a quick demo and then we'll answer some questions on this, hopefully for you folks too. So with that being said, let's go ahead and dive right into it. So when we talk about sort of observability user goals, this is where we spend a lot of time trying to help customers understand what's going on inside of their deployments. And so from a Google Cloud perspective, we are part of the Google Cloud Operations product team. There's products underneath that, monitoring, tracing, logging. But fundamentally, when we focus on this, we're trying to help customers do a couple of key things, right? We're trying to help them to detect and mitigate, discover an issue, figure out what's going on, and as quickly as possible. And the most common metric you might think there is mean time to resolution, right? We're trying to help people quickly figure out what's going on and resolve that issue. We focus a lot on root cause analysis, right? So one thing to resolve the issue. It's also another thing to understand what occurred, be able to dig into that and have the right data that's available for that. And then, of course, if you have both of those things, you can start to move to being sort of more proactive. And so we focus a lot on prevention as well once we have that information and helping people understand that. So whether that's new signals, new alerts, or automation to reduce those outages in the future, a lot of that stems from the ability to be able to measure and accurately understand what's going on. Prior to joining at Google, I worked on an automation tool set, and one of my favorite things was always being able to help customers figure out how to remediate and automate things quickly, and that always led me back to what are the signals coming out of a system, and how do we actually help make those useful for people. So when we think about sort of observability goals, we also have system goals. And so when we build those systems, they need to be scalable. They need to be able to grow as like the data plane needs to grow as needed. You need to have control over it. You need to be able to isolate failures and observability from production. It needs to be configurable, right? So it needs to react to active issues, tuning the fidelity to telemetry, whether that's the sampling rate or filtering on server side, those types of capabilities. You need to be able to enhance that data, and you need to be able to route it, right? So you need to be able to make sure that data looks the way it needs to for your systems. And also you need to have some flexible mechanisms for where you put that data, how you store it, what the duration looks like, or if you need to send it to another data system, how to be able to do that consistently. And for us, we fundamentally sort of believe this, and we'll talk a little bit more about this, but it needs to be open. And this is something that's not just this, a Google opinion. I think we're seeing this more and more as people build on, sort of establish themselves around OpenTelemetry and Prometheus, but we need to provide, one that's sort of a fundamental open source sort of positioning and standard, but you need to have your choice of observability tools. You need to be stable and standard, customization of those APIs, and you need a robust ecosystem, right? So being able to have most major vendors sort of playing in that space and understanding what's going on is fundamental for an open community to thrive and for end users to have choice around that space. So when we start talking about that, there's a couple of key sort of projects in the space, and two that Google is very heavily invested in. And the first one, not in any particular order, is OpenTelemetry. OpenTelemetry is really focused on a couple of key areas. It doesn't handle the visualization piece of this, and we won't be talking much about that today. But OpenTelemetry has a data model that allows you to sort of specify consistency around your instrumentation, collection and routing, and some of the conventions for when you're collecting telemetry. And that they have standards today for tracing, metrics, and logs, with tracing and metrics being a little further along in terms of development, and logs being the most new entrant to that. But it's a really exciting community in terms of having sort of one standard where multiple vendors and multiple organizations are committed to actually adopting this and making sure that it's useful for many different people and many different facets and how they come to the project. It's a single open source collection technology to instrument, collect, process, and export telemetry data from any source to a backend of choice. And that's sort of the big value of OpenTelemetry, is that you're starting to see this huge amount of community groundswell support around this, where you can reduce vendor lock-in, you can have flexible integration points, and everyone seems to be sort of marshaling behind that, which is really exciting. It is the second largest open source project in the Cloud Native Compute Foundation, the CNCF, behind Kubernetes. And you see lots of different vendors sort of working in that space, which is great. I think at the end of the day, we all win when organizations like ours and other organizations invest in open source projects like OpenTelemetry. And so when we start to look at this, sort of getting into some of the details, this is a really quick code snippet. We'll actually review this a little bit more in detail later today during the demo. But when you specify, this is an example of OTel instrumentation, a code example where we're setting up a metric. Now, one of the really great things about this is that you can specify this metric, you standardize it, and you can send it to almost any vendor in the space and have them sort of immediately understand and know what to do with that. And that's consistent for tracing, for metrics, and will be for logs as that standard matures. But here today, we're just looking at a really simple setup for the metrics. What does it mean to instrument something in Go with a counter or a gauge? In this particular one, we're actually looking at a counter, which you can see at the bottom of the slide here. There's not a whole lot to this. We'll come back to the demo, but what's really important, again, is when you think about OpenTelemetry, there's a couple of key pieces. There's the instrumentation level, there is the collection and the export levels as well. And not all of those have to be adopted in the same fashion. We'll talk about this a little bit more as Lee goes through some of the Prometheus work and some of the stuff in the demo. But one of the big key components here is, like, if you have an existing pipeline and you have existing sort of standards for some of these capabilities or metrics or traces, a lot of that can be handled through the OpenTelemetry collection and export mechanism. So you don't necessarily have to take all of it and rebase your code base on OpenTelemetry instrumentation. There's some advantages of that, but it's not absolutely required. And that's something that's really exciting to us, and I think exciting to a lot of our customers in this space. So with that, I'm going to pause and pass it over to Lee. As I mentioned, Lee is our managed service for Prometheus product manager, and he's going to talk a little bit about that space right now. Go ahead, Lee.
Thanks, Kyle. So for those that are not familiar with Prometheus, what is it? It is the de facto standard solution for monitoring. Something like 86% of the cloud native community uses Prometheus. Half of GKE clusters have it. For all intents and purposes, if you're using Kubernetes, you're likely to have some sort of Prometheus instrumentation or collection running within your cluster. Here is an example of how you might instrument a Prometheus metric. That being said, most of the time you're going to be using out-of-the-box libraries to do this, using exporters that other people have written. So it's pretty rare that you're going to be instrumenting your own Prometheus metrics. Prometheus is quite tough to run at scale within GKE. There's issues with getting Prometheus to work across clusters. There's issues with getting Prometheus to work inside of a large cluster, which is why we at GCP offer managed service for Prometheus, a global hybrid multi-cloud Prometheus metrics solution that can work for any deployment you have, still maintains compatibility with Prometheus. So here's a super high level architecture diagram. I'm going to briefly talk about different parts of this system, but basically we have a global metrics server called Monarch that we use for our internal metrics. What we've done is we have made Monarch look like a global Prometheus server. So you can basically point your Prometheus metrics at Monarch. You can point your Grafana or your cloud monitoring PromQL at Monarch, and get global Prometheus as a service without having to do much work yourself. This runs everywhere. I want to emphasize this hybrid and multi-cloud. Our collectors are based off of Prometheus and OpenTelemetry, so that those run everywhere. So that means that your metrics can be collected from anywhere as well. And likewise, because we have the PromQL API implemented, you can keep using Grafana if you want. You can use the Prometheus UI to query if you want. You can use cloud monitoring as well. So which standard is best between OpenTelemetry and Prometheus is a question that we get a lot. Which should I choose? And so let's break down the differences between the two briefly, because they're not exactly apples to apples here. So Prometheus comes with really, really strong community support. It is a much older project. And basically everything on Kubernetes will have an exporter, will have a GitHub repo with best practices in it that you can kind of just clone and get started with very little lift. A lot of people have existing Prometheus, especially if you're using Kubernetes already. And it's quite simple. It's because it only handles one signal. There's fewer moving pieces, right? It uses the Kubernetes API to automatically discover new things to scrape, so you don't have to do any instrumentation from within your application. And it really is as simple as like putting a couple lines of YAML as a config, applying it, and it just starts working. OpenTelemetry has strong community support, less strong than Prometheus, but it's growing, and very, very strong vendor support. I believe one of our OTel contributors on Inside Google said that it is the open source community that has got the fastest traction in all of history. Basically, every single major cloud supports it. Every single major vendor supports it. It's a single instrumentation choice for metrics, logs, and traces. So Prometheus is only for metrics. OpenTelemetry is for all three signals. And it's flexible. So it can also be used to collect Prometheus, also can be used to send to manage Prometheus. Ultimately, the question, which should I use, is somewhat of a false question because these two are complementary standards, right? You can use either Prometheus or OpenTelemetry to instrument your metrics. You can deploy either of them nearly anywhere, and you can send all that data to the same place, to cloud monitoring, to manage Prometheus, and query it all together. So in many ways, what I would say is if you're already using Prometheus, it's probably mostly straightforward to use manage Prometheus and the manage Prometheus collectors. If you're starting greenfield, or if you are trying to migrate from a mess of other standards such as StatsD or FluentBit or something like that, OpenTelemetry is likely your best bet. But you can absolutely mix and match these two and use them all together. So let's move on to Cloud Run here. And so Cloud Run, sorry, I think I just restarted, meant to look like Kubernetes. And basically it's deploy your container image, and it just works. Automatically scales up based off of load, automatically scales down when there's less load. And it's designed to make it so that you just deploy application code and don't even worry about any of the infrastructure. We handle all that. You just deploy your application container, and we do the rest. Why choose serverless over Kubernetes or any other environment? Higher velocity and productivity. So you're just working on application code. You're not figuring out how to deploy that. High reliability because we are doing all the SRE work, and lower cost. So you can pay based off of just the request that you're receiving. So it's really, really good for sparse applications that have sparse requests. But it's also effective, also cost effective if you allocate always on CPU for applications that receive constant requests. And just a little pull quote on the right there. It turns out that many people find that using Cloud Run is significantly more cost effective than just doing the number of VMs, mostly because you're only paying for what you use. You're not paying for the waste, and it auto scales very nicely. Yeah, it's more than just cloud functions. Like we do support functions, but it's functions, apps, containers. Per instance, concurrency gives you better performance, etc. It's built off of Knative, looks like Kubernetes. So you don't have to like kind of relearn the basics here. Just deploy your Docker image and it works. Sidecars, something we released very recently, a couple of months ago. But basically, much like a Kubernetes sidecar, you can deploy a sidecar alongside of Cloud Run container that interacts with that core application container. You can do many nifty things with that, such as add a proxy in front of your application, add authentication authorization as a separate container image that proxies in front of your application image, make sure that everything's authenticated, etc. But most importantly, at least for this conversation, sidecars let you send metrics and traces from your application to any supported endpoint. And why not logs, by the way? Logs are already supported natively in Cloud Run. So with that, I'm going to turn it back over to Kyle for a demo.
Thanks, Lee. Okay, so I'm going to go ahead and share my screen here. And so when we're looking at this, the first thing you're going to see is, before we sort of jump into what it looks like deployed and all that stuff, is I'm going to start here with the two projects we have. And so we'll have these in the comments a little further below. Like, so if you're looking at this later on, or if you want to actually try this out yourself, there's two projects I have on my screen here. They're both available on GitHub, and we're going to provide, again, links to that. You'll be able to sort of dig into this yourself and sort of see what it looks like. But at a high level, I just want to sort of talk through this. And so the one on the left-hand side of my screen is the OpenTelemetry example, and the one on my right-hand side of my screen is the Prometheus metrics example. Now, as you're going through this, so these are both Go applications, fairly simple. You'll notice that neither of these are instrumented for trace, and so I'll call that out now. We do have samples and examples of doing both metrics and trace, but just to sort of keep it simple today and help people get started, especially if you're running a job like a Cloud Run job that's a single job and it's not connecting to multiple services, and it's some kind of batch job, you may not have a need for strong tracing capabilities. And so that's why we decided to just do metrics today. But in some cases, if you're building sort of a full stack app, other reasons, you may want to do tracing, and that's totally possible. But so just to sort of come to it, like, first we were setting up a really simple web server in this one, where we have OpenTelemetry. We are setting up a really simple counter metric. And so again, I would say this is a pretty heavy lift in terms of what we're doing, just to sort of demo and sort of highlight this. But as you go through, we're setting up a web server. We are adding a metric incrementer, and so you can see that here. As the function gets called, we're going to increment this sidecar sample counter metric. You can actually see I've been running that down here, right? So I've been running this for the last 45 minutes, just to repeatedly get data and have this continuing to go through. But the big thing here is, with OpenTelemetry, you can instrument metrics this way. There's also pretty rich and sort of great auto instrumentation capabilities inside of OpenTelemetry. So depending on what you're looking to do, a simple counter for the number of requests, you can probably get that out of automatic instrumentation or auto instrumentation. But just to sort of highlight it and show what's possible, we like to just sort of start here with a pretty basic request. What we're going to look at now is sort of when we have this application, what does it actually look like to deploy it? In this sample, and as you go through the documentation for this, this is our cloud build deployment. And so what you're actually looking at here is, we're specifying a service. We're going to deploy this to Cloud Run, and we have two containers here, right? So in this case, this is the sample application. And if I expand this tab out a little bit, you can see the full title here. This is the sample application. We just looked at the Go for this. And then this one is actually our collector, right? And so we're specifying a couple of things here, but essentially we're offering this collector and saying, like, hey, we're going to get our metrics from here. Go ahead and start pulling it from it. And that's mostly it. There's a little bit here under the collector config, and I'll briefly talk about this. But if you're working with OpenTelemetry for the first time, you'll notice that you can set up your receivers. You can do a lot to process this. So under our processor section here, we're specifying things on like memory limits, how often we want to batch this. And as we go down, you'll notice that we're using a specialty exporter here. We're actually using the managed service for Prometheus export. What Lee mentioned a little bit ago about being able to use OpenTelemetry and Prometheus together is we're actually going to be sending OpenTelemetry metrics to Google Cloud's managed service for Prometheus. So even though we're setting this up and instrumenting it as an OpenTelemetry metric, we're actually still able to send this to the managed service for Prometheus endpoint, and that sort of unlocks all the additional work that we have inside of the environment. So that's sort of really quickly it. I'll come back to this, but just to highlight, the counter we have right here, and the name of that counter is a sidecar metric, right? So we're going to call it the sidecar metric. Let's switch over to the Prometheus example, which is on this side of my screen. I'll just expand this one out a little bit. So the structure of this project looks a little different, so I'll just call that out. And again, we have documentation for both of these, so I wouldn't worry too much about it today as you're following through. But if I go to my sample application, we'll look at the simple app here, and I'll go into the main Go file for this as well. You notice we're setting up a lot. So on the Prometheus side, there's some specifics that we're describing here. Lee mentioned a lot of the time, especially for people getting started with Prometheus, going straight into instrumenting your own applications, probably not where you're going to start. Especially for people who are on Kubernetes or coming from the Kubernetes space, there's a number of available exporters and things you can get out of the box without having to do any of this instrumentation work yourself. And we would strongly encourage people getting started to start there. We actually do most of our documentation on Kubernetes engine, on Google, as well as for other deployments, to start with those exporters. That's probably the easiest way to get started and understand what's going on with Prometheus. Similar to OpenTelemetry, there's a bunch of SDK and libraries available to make it easier to instrument your applications. I happen to use a lot of in my free time. I do a lot of my coding in Python, and so both OpenTelemetry and Prometheus have libraries for like the Flask libraries to make it easy to get started with instrumenting Python APIs, those types of things. So again, this may not be where you start, but it's helpful to understand where you're looking at, and when we're specifying a new metric, what we're actually collecting. Above this right here is where we're actually setting, a new metric called foo, and you're going to see that it's going to be titled foo metric, and the other one here is the bar metric. So that's sort of it. We're setting up these two metrics. We're specifying how we increment these when we instantiate them, and you can see, user request received, very similar response. It's a web server that we're going to initially create this metric and then sort of move on from there. So if I go back into a little bit of the work here, this is our build file for getting this service to run inside of Cloud Run. And again, what we're doing is we're specifying, the sample image that we have, and then we're also specifying the GMP sidecar. What's really nice about this is all you have to take care of is your app. And so in both of these examples, if you want to use Cloud Run and you want to instrument with either OpenTelemetry or Prometheus, you specify your app, you take care of this part, and then all you have to do is make sure that you attach that sidecar container that we provided. So whether that's the GMP one or the OpenTelemetry sidecar, you don't have to do any of that work there. You just make sure that your metrics are available, and we know how to find it from that point just based off of the configuration. So sort of getting back to this, at the end of this, I have, my very simple web server running down here. I've just been incrementing this over time as I've been talking. But now we're going to take a look at what this actually looks like in the Cloud Console. So first, I'll start here. We have our two services. I have my Cloud Run service and my OpenTelemetry sample service. If I click into this, we can briefly see a little bit of information about this service. So I'm going to change this interval because I've only been running it for a couple of, an hour or so at this point. So if I set the last 30 minutes, we can see that the service has been going. That looks great. If I take a look at the revisions, I can see a little bit more about this service, right? As Lee mentioned, the sort of key thing here, what's really interesting, what's been helpful is the ability to provide sidecar containers. And so if we look at the sidecar container, we can see, this is the actual application container where we've deployed it. And then this is our collector container. This one is the managed service for Prometheus one. And this is running just fine. Everything looks good. Similarly, under the OTel one, if I click into here, and again, if I look at the revisions, we can see there's really not a ton of magic here, right? It's just that we have tried to make this as easy as possible for you to get set up. And so again, we have our application container that is running, and then we also have our collection container, which is the OpenTelemetry collection one in this particular example. So, again, you figure out what you're doing on the app. We're specifying this endpoint where we're going to collect metrics from, and that's it. Now, one of the cool things under sort of the hood of this is if you look at, if you go through this project and you go back and look at it, we're using the OpenTelemetry exporter for both for the OTel and for the Prometheus examples. So the way all this stuff is being ingested and the way we're collecting it is essentially the same at the end of the day. We're using Prometheus to instrument in one example. We're using Go to instrument in, we're using OTel to instrument in the other example. But both are actually being collected by OpenTelemetry and then being sent to managed service for Prometheus. And so that makes it really easy to have sort of a centralized location for all this data. Let's take a look at that. So What I've gone ahead and done just to make sure that I had it ready for this is, again, I've been building this out for running this for the last hour or so. I can probably expand this if I wanted to the last hour. But you'll see that I have 3 things here. And if you're not familiar with cloud monitoring, this is our metric builder sort of view. I can add additional queries if I wanted, but if I click through into here, you can see that I have the bar metric selected. I have the counter. You can see a little bit more about this. We can see that it's a Prometheus target. Similarly, this is the foo metric that I have set up. And so we saw earlier, this is coming from the Prometheus instrumented app. And this last one is the sidecar sample counter, and that's coming from OTel. There are different types of, again, instrumentation that we're able to apply this and visualize them all together. You'll see that there's 2 up here, and then a further one down here, right, where this is, again, a pretty simple counter. And so you have a lot of flexibility in terms of, one, again, in what it looks like at the instrumentation layer, the collection layer, and then the visualization layer. If you're using this inside of our visualization tools, you can query this, you can create dashboards. I could save this to a chart if I wanted to. And then I can use all the other things inside of cloud monitoring, like uptime checks or alerts to sort of make sure that this service is running reliably in addition to our metrics. Or if you're looking at the logs for this application, you can check out the logs that we automatically collect, as Lee mentioned before. Anything sent to standard out, standard error, sort of a container best practice automatically gets captured. So we have a lot of flexibility and a lot of different ways to use these. If you're using third-party tools like Grafana or another visualization, you have full access to these Prometheus metrics through that tool set too. If you use logs and trace there as well, you can also use our integrations with Cloud Logging and Cloud Trace to visualize them all within Grafana. So there's a lot of different ways that we're trying to make this one easily composable, but also easily consumable so that you can get value out of it however you need to. Just to sort of briefly come back to this, in addition to this sort of metric builder, we also have the ability to run raw queries. So if I just wanted to get I'll just pick the sidecar sample, and if I want to do a 5-minute interval on this, I can go ahead and build that out, hit run query, and we can sort of see a visualization of this sidecar sample counter. So that was a really quick sort of demo of what's happening here, but hopefully you sort of get the feel for what does it look like to deploy this? What does it look like to instrument? How do I actually get this stuff into Google Cloud's massive scalable time series system? And then what do I do with it? How do I actually make it useful in terms of visualization? We're going to go ahead and flip back to the rest of the presentation, and we'll start going through Q&A and answering any questions right now. So actually, before I do that, and I realize now we have resources on what's next. So if you want to jump through this, you have the Prometheus sidecar demo, the OTel sidecar demo. We recently did an OpenTelemetry webinar for GKE. So that was done in October. And if that's sort of where your starting point is, that can be useful for you to get started with. The last thing I'll say is we also have a bunch of additional events coming up that we would encourage you to take a look at if you're sort of exploring Google Cloud. So now we're going to jump to the Q&A, and let's take a look through here. First, I think we had a couple of pre-submitted questions. Looks like we have a few in the queue, but I'll start with the pre-submitted one. So the first one we have was, I have a Prometheus server which is installed on a VM instance. Can Cloud Run be monitored with Prometheus and viewed in the Grafana dashboard? So I don't know if the person who originally submitted this question was able to attend today. We weren't totally sure how to answer this, or maybe Lee and I interpreted this 2 different ways. But the way I viewed it was, if you're using Prometheus locally on a VM, let's say to capture metrics like nodes, node exporter, and you're sort of just sending that to a local Prometheus server, there's probably not a lot Cloud Run gets involved with here. But what I would say is that in Google Cloud, if you're running that VM inside of Google Cloud, you can use our ops agent to collect Prometheus metrics from the ops agent. So, the ops agent will provide a lot of information by default. So if you turn that on for the first time and you're using that to collect system metrics, you can continue to use those, or you can also use Prometheus metrics based off of your own custom configuration. If this VM exists outside of Google Cloud, you can use OpenTelemetry to submit that to our managed service with Prometheus, and certainly view it in a Grafana dashboard. This might have just been the way the question was phrased, but again, I'll say, like, if you're on GCE, I would encourage you to use the ops agent. You can use that to send Prometheus metrics to us, and you can visualize that in Grafana, in Cloud Monitor, wherever you want. The second one was, what about CloudTrace? This is a great question. We didn't provide anything for CloudTrace today, although it is totally supported. And I would say, again, depending on how you're building your Cloud Run services, if you're building them as like sort of batch jobs where that function executes and then exits, you may not need tracing sort of end to end, right? You can get automatic tracing with the auto instrumentation pretty easily. If you're just looking to see what, how long that function is performing, or you want to get specifics out of the traces there, you can definitely do that, and it's totally supported. We do have more on the tracing capabilities of OpenTelemetry in the GKE webinar, and I think we'll probably do another one of these in the future on Cloud Run, sort of building more advanced architectures to actually show that demo. But we didn't include it today just to sort of keep the discussion between metrics when you're debating on OpenTelemetry metrics versus Prometheus metrics. We also support, if you use OpenTelemetry tracing with Prometheus, we also support exemplars in managed service for Prometheus, so you can correlate those together too. If that's something you're looking to do. I think that's it for the pre-advanced slide. So let me go ahead and take a look at the questions here. Give me 1 second. So this first question from Tomek was pretty cool. So Cloud Run can be treated as pods now with option to run multiple containers at set similar to K8s. Are there any major differences and limitations? So yeah, I mean, the short of this, and Lee, feel free to jump in, but like this is one of the reasons that the sidecar functionality was introduced. Although Cloud Run has been historically a really lightweight way of sort of adopting containerized workloads, there were just certain situations where we needed that sidecar functionality, and even for us, right? Like there were some challenges with making instrumentation easily available, with making it clearly understood, like where the metadata was coming from on these metrics. So the sidecar value definitely unlocks a lot of that, but I think there's definitely advantages to it beyond just our use case, which is obviously the instrumentation focus. So good question.
In a nutshell, the answer is more or less you can treat it like a pod instead of a container. However, sidecar containers can only know about their the service container that they're attached to. So you don't have anything like a Kubernetes cluster still that you can ping or get information about. It's still like each instance is still self-contained, but the sidecar containers can do things with the main instance in that service. Next question. Is there a G-Cloud command to add sidecar instead of editing the Knative service YAML for deployment? The answer is not yet. It's on our roadmap. We're likely to actually use Cloud Run integrations in the console, which will have G-Cloud integration, where you can basically deploy a pre-defined monitoring or OpenTelemetry or Prometheus sidecar. But at the moment, no, you have to edit the YAML. It's about 2 to 3 lines of YAML to edit. So hopefully it's not too much of a burden.
Yeah, and I think the one thing there is also just like, although it can be easy to get sort of started with this, to Lee's point, the 2 demos we provided, it's literally you're adding the additional container spec for the sidecar. It's not too heavy of a lift, but it's also really important to, I would say, focus on your files. Don't focus on command lines, right? Like as often as you can, you start building that habit of source controlling what you're building and what you're deploying. And so maybe you're using Cloud Run or the G-Cloud commands in sort of a systematic or programmatized way. But we would really encourage some level of source control and putting those files into the right location so that you can deploy them rapidly and iterate on them and make the revisions easily handleable. Lee, it looks like you're going to answer that. Sorry.
Is there an option to add a sidecar to an already running service in more or less non-disruptive way? Adding a sidecar to a service is a revision change, so you would have to redeploy the service. That being said, you can non-disruptively redeploy the service. So I think the answer is yes here. Just have to upgrade the YAML and then redeploy it.
Yeah, there's actually, and just like if you're interested in doing that specifically, for the managed service for Prometheus documentation, we actually provide an example of this, right? To to add the sidecar to an existing Cloud Run service. And I would encourage you to check that out. That is from the links in the show notes, or the recording notes, I should say. Although I'm not opposed to Lee and I starting a show together if you want to do that, Lee. But from the recording notes, the guide for adding it to an additional service is there. So. All right. So I think that wraps for all the questions that we had. Thanks so much again for everyone's time and for attending. We hope you guys, really enjoyed this. Hopefully you learned something new. You can add questions to the community forums, as we just mentioned in chat. We're in there regularly. We always want to hear feedback on what this looks like and how we, how we'll be able to improve this for customers. We'll also be at Google Cloud Next in Las Vegas this year, next month. So if you want to talk to us more about this, please feel free to reach out to me and Lee, as well as a bunch of other folks that we have there. But and also please provide feedback to the event today. Again, this helps us make sure that we build more of these and either make it more technical, we make it less technical, maybe provide a hands-on element in the future. So if that's of interest, please do that. And thanks again for joining.